Ever pondered about how the human brain processes information? It's a complex system of interconnected neurons that take in data, process it, and output a response. Now, imagine if machines could mimic this process. Welcome to the fascinating world of neural networks. Neural networks form the basis of artificial intelligence, enabling machines to learn and make decisions like humans. These networks, much like our brains, comprise numerous interconnected nodes, or neurons. Each neuron receives an input, processes it, and passes it on. This input can be anything: a number, a word, a picture, or a sound. The power of a neural network lies in its ability to learn from data. It does this through a process called training. During training, the network is fed a lot of data and is tasked with making predictions. When it gets a prediction wrong, it adjusts its internal parameters slightly. Over time, these adjustments help the network make more accurate predictions. But how does a neuron know what to pass on? Well, this is where the concept of activation functions comes in. An activation function decides whether a neuron should be activated or not, meaning whether the information that the neuron is processing is relevant for the given information or should it be ignored. There are several types of activation functions, such as the sigmoid, tan, and ReLU. Each has its own advantages and disadvantages, and the choice of activation function can significantly influence the network's learning process. Now, let's delve into the basic architecture of neural networks. The simplest one is the feed-forward network. In a feed-forward network, information moves in one direction only, from the input layer, through the hidden layers, to the output layer. There are no loops in the network. Information is always fed forward, never back. However, it's crucial to note that while the feed-forward network is the simplest, it's not the only architecture. There are more complex ones like convolutional neural networks and recurrent neural networks, which are used for more complex tasks, such as image recognition and natural language processing. To summarize, neural networks are powerful tools that allow machines to learn from data. They consist of interconnected neurons that process and pass on information. Activation functions play a critical role in deciding which information is relevant and should be passed on. And finally, the architecture of a neural network, whether it's a simple feed-forward network or a complex recurrent network, determines how information flows through the network. Remember, neural networks are not just about complex equations and algorithms. They're about creating systems that can learn and adapt, much like our own brains. The journey of understanding neural networks is a thrilling exploration of how we can make machines think and learn like us. Stay curious, keep learning, and until next time, keep exploring the world of artificial intelligence.